Hello and welcome, class. Today I am going to be going over how to predict synthesis reactions, which is one of the 5 types of chemical reactions that is generally gone over in chemistry. Now, synthesis reactions are typified by being with one product, meaning in the end you are going to see one product. So we are going to do the synthesis of potassium and selenium. You can see my directions that are just below here. First thing we're going to do is we're going to write down the reactants that we are dealing with. Now in this case we've got potassium, which is going to be a K. We're then going to put a plus and we're going to put selenium, which is Se. This is all we're going to do for the reactant step right off the bat. We're then going to check to see if either of these are social, which is another way of saying diatomic, meaning they cannot be alone. Neither of these are social, so life is good and we move on. Now there's only one product that's going to be here when it comes to our synthesis reactions, so we're going to put both potassium and selenium together. But in order to do that, we need to know how many of each we're going to have. So I'm going to sit there and have my potassium and selenium set, but to determine how many of each, I need to look at charges. Now, potassium is a 1+ charge, whereas selenium is a 2- charge. We will then need a second potassium to cancel out our selenium. So 2 potassiums to 1 selenium, that will be our canceling ratio. So we're going to wind up with K2S, or potassium selenide, as our product. I do not want to keep my charges around, so I'm going to get rid of them. Last but not least, I balance. I've got on one side I've got potassium, on the other side I've got 2 potassiums, so I want to make sure that the reactants match the products. So I am going to make sure that there is going to be 2 potassiums on both sides. This balances out the whole thing, and we're done. So our first one, set, not a big deal. This was pretty easy. There was really no tricks in this first one, but that's good. You know, when there's no tricks, we can focus on the stuff that's most important. Now the next one is going to have some tricks with it. We are going to be doing the synthesis between chlorine and gallium. Now there are actually a couple tricks with this, and I will go over them as we get to them. First off, I need to write my reactants down. So I'm going to start with my chlorine, ICl, capital C, lowercase l. And then I'm going to put gallium there, little g, not capital A, but little a. Now, it's okay that we write them like that there, but I need to check to see if either of them are social. And look, there's our first hurdle. Chlorine is indeed social, which means it cannot be alone, even when it looks like it's alone. So we need to put a little 2 there to make sure that it is fine. At that point, we want to combine these, and that's where our second issue comes in. When I put these together, you're going to think that maybe the chlorine should go first, but it should not go first. The chlorine is negative, the gallium is positive, so gallium goes first, not chlorine. And gallium is going to be combined with chlorine, and as I did it that way for a reason, you're going to find out that has to do with charges. Chlorine is a -1 charge, whereas gallium is a 3 positive charge. This means I'm going to need 3 chlorines. Now don't get confused. It's only going to be 3 chlorines, not 6. Even though there is a 2 there, that's not going to be what does it. What does it is just the element itself. So we have got 3 chlorines to 1 gallium. That just means that we put our 3 as a subscript below. We then get rid of our charges because we do not want charges in our final answer, so boom, gone. Last but not least, I need to balance this sucker. Shouldn't be that big a deal. I got 2 chlorines on the reactants, 3 chlorines on the products. I make them both into 6. That makes them nice and balanced. And as I look, I then have 1 chlorine in the reactants, 2 chlorines in the products. So I put a 2 there, and we're done. Everything works, so we're good. So this had 2 problems with it. The first problem was chlorine was social, meaning it could not be alone, so we had to make sure we put the little 2 there, which is shown in green. The second problem is that this question had the negative thing mentioned first. That does not mean that it is first in the compound. When you have the compound, it has to be the positive one first, not the negative one. So that was our slightly trickier question. Okay, so I'm just going to get rid of this, and we're going to go down to our third and final question. and that is vanadium 5. That's what that V means. A V in Roman numerals means 5, and sulfur. So first, again, we are going to work with our putting our reactants down as our notes there say. So we are going to do vanadium and sulfur. Neither of these are social, so life is good. There's really nothing big that we have to do there. Then I'm going to sit there and put them together. So I have my arrow, give a bit of space, vanadium and sulfur. Vanadium being positive, it goes first. Now, so that's my kind of rough setup, but how many vanadiums to how many sulfurs? Well, that all has to do with charges. Now that little V for the Roman numeral that's there, that's telling you that this vanadium has a 5+ charge. And that's weird just because vanadium is weird. Vanadium can change its charges based on situations, and this vanadium happens to be 5. The problem will give you some way to figure that out. You can check out a video on making multi-charged ions, and that will show you there. But if we're doing 5 positives versus 2 negatives, we want to make them both equal to 10. That means we're going to need 2 vanadiums, and we're going to need a whole bunch of sulfurs. So much that I couldn't even decide to go down. I'm going to need 5 of those suckers. So I need 2 vanadiums and 5 sulfurs to make sure that works. And there we go. I then need to, of course, balance this. I've got 1 V on the reactants, 2 V in the products, so that is a quick and easy fix. 1 sulfur in the reactants, 5 sulfurs in the products. That is an easy fix. Make them both into 5, and then everything is balanced. I get rid of my charges because charges should not belong in the final answer that you give, and there we go. 2 vanadiums, 5 sulfurs becomes V2S5, or vanadium 5 sulfur, because that Roman numeral 5 is just the charge. I hope this video was helpful to you in predicting synthesis reactions, and that's one less thing you have to worry about. Take care and stay safe.